Starting today's class, this is the MCQ from 2.2, question number 35. The question says two identical perfectly elastic spheres have the same mass m. They travel towards each other with same speed v along a horizontal frictionless surface. Which statement about the sum of the kinetic energies of the spheres is correct? Now you need to understand that it's asking you that which statement about the sum of the kinetic energies of the spheres is correct, which means you're supposed to calculate the kinetic energies and then add them together. And the question also have told us that they are perfectly elastic spheres, which means the collision would conserve kinetic energy. So the option says the sum of the kinetic energies before impact is 0. This is not correct because kinetic energy is not a vector quantity. You just do half mv square plus half mv square, which gives you mv square. It's not 0. B says the sum of the kinetic energies before impact is half mv square, also not correct. The sum of the kinetic energies after impact is 0. This is also not correct because they are perfectly elastic spheres. So after collision, they should have some kinetic energy. The sum of the kinetic energies after impact is mv square. D should be the correct response because that's what makes sense.
Sir, আমি ওই যে 36 এর অ্যানসারটা ভুল করে দেখছি, তো মনে হয় সি দেওয়া, দেন আই টিক সি এন্ড দেন আই ওয়াজ কনফিউজড। ওইটা ডি ভাবছিলাম স্যার, তারপর বুঝছি স্যার।
আচ্ছা, বলো। So today we're going to pick up, হ্যাঁ বলো।
স্যার আমরা যেটা ফলিং অবজেক্টের যদি আর্থ এন্ড অবজেক্টটাকে একটা এন্টায়ার সিস্টেম কনসিডার করি, এটা কি মানে মোমেন্টামে টার্মসে দেখলে কি হবে স্যার, এটা বুঝি না স্যার। কয়েকটা কোশ্চেনে জাস্ট পেয়েছিলাম, তাই।
হ্যাঁ,
পেপার 2
দেখাচ্ছি আমি। এটা পেপার 2 অনেকগুলো কোশ্চেনে এই কোশ্চেনটা আছে যে ফ্রি ফলিং বডির ওয়েট রিলেটেড মোশনের জন্য মোমেন্টামের চেঞ্জ বা কনজারভেশন অফ মোমেন্টাম, লিনিয়ার মোমেন্টাম আমরা কিভাবে অ্যাপ্লাই করব ওটা দেখাচ্ছি তোমাদেরকে। আজকে আমাদের অ্যাকচুয়ালি পেপার 2 স্টার্ট করার কথা, কারণ লাস্ট পেপার 1 এর কিছু প্রবলেম সলভ করছিলাম। সো you can start paper 1 today and I'll try to choose some problem of my own, and if you have some problem that you have attempted and would like me to discuss, all welcome.
স্যার কোশ্চেন নাম্বার 4 স্যার।
আচ্ছা দাঁড়াও। আচ্ছা, কোশ্চেন নাম্বার 1 কি পারা গেছে? আচ্ছা, আমি কোশ্চেন নাম্বার 1 নিয়ে ছোট একটা হেডস আপ দেই। Like the way I told you in the earlier class, for one of the MCQs that we have solved in this paper, which was for the case of this one, stationary block and lead pellet hitting the plate by some speed, that this MCQ cannot be attempted by the conservation of energy concept because some kinetic energy would be lost in the process of deformation or the objects getting merged together. Eta kora jabe na. That same logic is also applicable for this question as well. The bullet comes in with some mass and with some initial velocity. It hits with the wooden block. You cannot consider that the kinetic energy of the bullet would be conserved after the collision because there is a case of merging. The bullet gets into the wood block and gets stayed there, which is two objects getting merged together. So there will be loss of kinetic energy. So you have to do this in two different steps. First, use conservation of linear momentum to find out the final velocity of the combined object after collision. This final velocity after collision should be considered as the initial velocity for the rise. Use that to calculate out the part, and that's how you should solve this problem piece by piece. I just told you the outline for how to attempt this problem. I'm not going to do the whole question for every part. It's pretty simple. You can try this on your own. If you get stuck at a specific question or if you cannot solve something, I'll help you to do that. Pojomo, thank you. To make a problem this, so I'll solve that as well. I'm just going to skim through this paper for questions which essentially require some discussion. Question number 2 is a pretty interesting one. I'd like to discuss one thing about question number 2. Question number 2 তে একটা জিনিস দেখো, an experiment is conducted on the surface of the planet Mars. A sphere of mass 0.7 kg is projected almost vertically upwards from the surface of the planet. আচ্ছা আমি এখানে একটা জিনিস তোমাদেরকে একটু বলি, সেটা হচ্ছে পেপার 2 তে এটা আসলে আমাদের measurement chapter খুব একটা ছিল না, but from this chapter onwards, even all the way up to A2 level, you'll see that pretty much in many cases, not in all cases, in many cases after a significantly long structured question, you'd find this kind of a state and explain kind of question, that they're going to give you a additional scenario. For example, maybe you did an entire sum without air resistance, then in the last part they say considering air resistance to be not negligible, how would the whole thing would vary, state and explain in your own words. You're going to find these kind of questions quite often. It is very important that you pay good attention to this question. Finding out the mathematical answers is definitely a big deal, and if your concept and application of formula and calculations are okay, you should get the mathematical answers pretty correct in most of the cases. If you can't, I'm here to help you. But these questions, which are state and explain kind of questions, which should be explained in words, and these are actually a test for how well do you understand the concept, and also at the same time, plus how well can you articulate the concept for the regarding scenario that they have provided. So it's important that you pay good attention to these things and try to revise these questions, this kind of questions, which is at the very last end of the question paper, whenever you get a chance. So if you have a test coming up in your school or in my coaching, do keep in mind that these questions do require some serious attention, both for the mark schemes and the examiners report, so that you do understand what were you expected to write and how should you write that, and why other form option of writing is not correct. Try to read the question. In case when you are trying to revise these questions, try to read the questions, try to guess the answer in your head, then go check your mark scheme and examiners report, and then refine the answer and slowly move on forward. These questions do require additional attention. That's the whole point of this long talk. Question number 2. An experiment is conducted on the surface of the planet Mars. A sphere of mass 0.78 kg is projected almost vertically upwards from the surface of this planet. The variation with time t of the vertical velocity v in the upward direction is shown in figure 2.1. Okay. The sphere lands on a small hill at time t equals to 4.0 seconds. Okay, this is the end point when the hill it hits on a hill. Say the time t at which the velocity at which the sphere reaches its maximum height above the planet's surface. Determine the vertical height above the point of projection for at which the sphere finally comes to rest on the hill. Determine the final vertical height above the point of projection at which the sphere finally comes to rest on the hill. Finally comes to rest, which means not the highest point. Calculate for the first 3.5 seconds of the motion of the sphere, the change of momentum of the sphere, the force acting on the sphere. Using your answer in C3, state the weight of the sphere, determine the acceleration of free fall on the surface of Mars. Okay, there are a couple of key questions over here which we need to consider. First of all, one of the important bit that I would like to take your attention is that this question is about the vertical velocity. This is important. What they are trying to show you that whenever at the instant of position, the vertical velocity was 9 meters per second. This is the 9 value over here, and then the vertical velocity, upward velocity reduced to 0, and then it became negative, which means this would represent, this 0 velocity point would represent the maximum point of maximum height of reach. So the object, the height that the stone, is it a stone or sphere? The height that the sphere did reach above the point of projection. Point of projection means from the point where it was shot from the point where it was shot. So this is the height that it got from the point of this area under the triangle is the upward height that the object traveled, and the area under this triangle is the downward fall that the sphere did. And as you can see that this area is bigger, this area is definitely smaller. That's also what is mentioned over here, that it landed on a small hill. So the difference of these two areas basically gives you the height of the hill. This is the rise height, this is the fall height. Difference gives you the height of the hill. That's pretty much it for this part. And over here you have another question that the change of momentum of the sphere. This is basically m into v minus u, and the force acting on the sphere would be the total momentum change divided by the total duration of time. That gives you the force. Using the force, you can find out the weight. Basically the force that you are having over here would be the weight, because when the object is going through the vertical rise and fall, considering air is negligible, the weight is basically the force that causes all the acceleration. So you just mentioned this same value over here, and just to understand that this force is basically the weight is the force that is responsible to cause the motion. Considering a resistance to be negligible, we have to write that. So that scores you 1 mark for this question. And then to find out the acceleration, you just have to do F equals to ma. Determine the acceleration of free fall on the Mars. So you can either do that would be the easier way to go for it, or you can also find out the gradient of this graph. That can also give you the acceleration of free fall on the surface of the planet Mars. So all of this process can happen individually. Be very careful to not to mess up your unit in your calculations. That's really important. Yeah, I have 2 raised hands. Hassan, go up.
স্যার আমাদের যদি বলে t equals to 6 বা t equals to 7 পর্যন্ত যদি টাইম দেয়, আমাদের নিজের গ্রাফ আঁকতে বলে যে draw the graph after the ball lands on Mars, তাহলে কি স্যার নিউটনস থার্ড ল ওয়াইজ একটা ভার্টিক্যাল লাইন আঁকবো যেটা অনেক অ্যাক্সেলারেট করে লাইক ফোর্স, নাকি জাস্ট এক্স অ্যাক্সিসের সাথে মিলাই দিব?
Well, so you're asking me that this is I mean, let me understand your question properly. As per the question, it says that at 4.0 second, the sphere landed on a hill, and that's where it came to rest. So what you're asking me that if the particle has to come to rest at 4.0 second, if that whole deceleration happened within an instant of time, shouldn't that deceleration has infinite value? That's what you're asking me, right?
না স্যার, লাইক ওটা ইকুয়াল হবে না যে ফোর্সের নিচে নামছে, পরে গ্রাফটা যদি স্যার রেস্টে একেবারে রেস্টে না আসে আর বাউন্স করে, তাহলে কেমন হবে স্যার?
Also, you're asking me that how the graph would look like if it was a bouncing ball case.
জি স্যার।
Okay, that I can explain. Do you have the note of bouncing ball in your class notes within this chapter?
জি স্যার, একটা গ্রাফ দিছিলেন স্যার, যে বড় থেকে ছোট হইতে থাকে।
আচ্ছা, বলতেছি। I can actually draw this pretty easily and help you understand what happens. Acha, for those of you who didn't catch what we were discussing, what Hassan is asking me that if we have a case for a bouncing ball, how would we describe this individual behavior? So this is what might look like for the case for a bouncing ball graph. I need to work on my skill of straight line drawing. Okay, let's try now.
স্যার
জি বলো।
I got disconnected. স্যার আমাদের যে চেঞ্জ অফ মোমেন্টাম আমরা ভেলোসিটিস গুলা শুধু অ্যাড করে দিই কেন, সাইন কখনো কনসিডারেশন নিই না কেন?
কখন?
মানে ভেলোসিটিস মানে চেঞ্জ অফ মোমেন্টামে জাস্ট ম্যাস ইনটু যে ভেলোসিটিস যদি জাস্ট অ্যাড করে দিই, আমরা যদি একটা অপোজিট ডাইরেকশনে থাকেও যদি ফাইনাল ভেলোসিটি যদি মাইনাস হয়, ওটা আমরা মাইনাস ধরি না, জাস্ট অ্যাড করে দিই দুটা। কেন স্যার?
No. We do consider that. Here's the deal. If you are applying the formula of conservation of linear momentum, for example, m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2, you have to consider that if the 2 objects were going in the same direction initially, we have to place both of them with the same sign. But if one of the object was going right and the other object was coming from going towards left, then while you are gonna place the value, mass will have a positive value, there is no question about that. But in the case of opposite direction for the before collision, if you place one value to be positive, the other value must be placed as negative. That is very important. We do not essentially change the expression of the equation, that we find out the conservation as the sum of the initial momentum. m1 u1 plus m2 u2 pretty much remains the same, but depending upon the initial direction of the 2 objects before collision, we have to give individual sign in the placement of their velocity values. So it comes down from the idea that how you are gonna how you perceive the whole scenario, and whether they are moving in the same direction or they're moving in opposite direction with respect to each other. That this is the key part. And as for the consideration for relative velocity, I mean speed of approach and speed of separation, that's just a simple way to calculate to tell whether the objects will have elastic collision or not.
Yes, sir.
বুঝছো?
Yes, sir.
আচ্ছা। So let's try to understand this part, what is happening. So let's say we are considering upward as positive direction, so we're going to try to draw the velocity time graph for a bouncing ball. Just to make sense with you, I'm going to try to draw a physical scenario. Let's say this is the ground, and then let's say we are going to drop a bouncing ball from this height, and the ball is going to fall downwards, speed up, and hit the ground with some high velocity, then bounce upwards. And if we consider for an unrealistic scenario, let's say if it's an elastic collision with the ground, which is highly unrealistic, elastic collision never happens. In that case, all the kinetic energies will be conserved within the ball, so the ball would be able to rise up by the same amount of height. So first of all, I'm going to drop that graph. The way this graph can be drawn is something like this. Have a look. Let's say we're going to draw a negative acceleration graph. Let's say this is the final velocity at which the particle, the ball hits the ground. Then the collision is going to happen, and for the collision process to occur, there has to be two processes. First of all, the ball should compress, in which process the kinetic energy will be stored as elastic potential energy within the ball, and it will eventually decelerate. The center of gravity is going to slow down of the ball, and when all the kinetic energy will be converted into elastic potential energy, the ball would stop compressing any further. Then the ball is going to start expand. And in the process of expanding, the center of gravity of the ball is going to start to rise upwards. And eventually, when all the expansion is done, the ball reaches its original shape. That is the instant when the ball is going to leave off from the ground. Both of these incidents, compression and decompression, I'm not going to say expansion, I'm going to use the word decompression. Compression and decompression happens within a very short amount of time. That's basically the contact duration within which the ball is in contact with the ground. Within this part, the entire velocity of the ball will change in the upward direction. So if the scenario is such that the ball undergoes elastic collision, then we are going to have the same amount of velocity in the upward direction. So this is the initial fall. This is the first collision. Let's say the collision takes 1 division time over here, which is highly unlikely. I should not give 1 division. Let's say a smaller part. So I have drawn 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So let's say 1, 2, 3, 4, 5, 6. So let's say the collision takes this much time. So we need to draw up a straight vertical line from this point all the way up over there. This is supposed to be your collision. Then when the collision is done, this is the point where the ball leaves off the ground and starts its upward journey and maintain the same acceleration as this one, because this was falling under gravity, and now here this will be rise against gravity. So the gradient of these two lines should be exactly same. This is the point of the maximum point of rise. So provided we consider this whole process as a perfect elastic collision, this area under this whole triangle and the area under this triangle should be exactly same, considering that no energy is being lost. So the ball is gonna rise up by the same value. So I'm going to talk about the energy considerations part by part, and then this should rise all the way up to the exact same height. Let's say somewhere over here. My drawing is not being perfect, but they should be parallel to each other, and then the same cycle would follow. So it's going to have a really sharp bounce, let's say right all the way up over here within a very short time, and this process is just going to continue. This is the graph. That's what should have happened if you consider perfect elastic collision, but there is no kinetic energy loss from the ball. The type of energies involved over here are GP, K, EP. That's it. We are considering no heat energy or sound energy out of this process. That's a simple graph. On the other hand, if you consider this to be a more realistic scenario means that, let's say, the ball does lose some kinetic energy. In that case, the initial fall in height should not be as much as the afterwards rise, which means in the process of collision, some energy would be lost, or the collision would not be perfectly elastic. So the simple thing is, in that case, this collision is going to happen, but the rebound speed, I'm using the term speed, would not be as much as the hitting speed, which means it's going to be somewhat less. Let's say I'm going to draw it to 1 division less. And then the ball takes off, and once again this part, which is the rise of the ball and then eventually fall of the ball from the highest point, would once again be parallel with the initial line, because that represents the acceleration due to gravity. And if you consider air resistance to be negligible, we should consider air resistance to be negligible. We are considering air resistance to be negligible for this example. In that case, this area and this area, which is going to be our next collision, let's say the next collision happens like that, these two areas should be exactly same. This is the first fall, this is the first rise, this is the second fall, and then there will be the second rise, and that should be somewhat less as well. So I drew you over here to be 5 division. Let's say I'm going to draw it for 4 divisions over here, and once again parallel line like that. And so this, let's say this is our second rise. So what is important, that the fall and the subsequent rise, the fall and the subsequent rise would not be equal, because we're going to have lost some energy in the process of collision with the ground. This is where the energy is going to be lost. But any rise and the subsequent fall should have the same distance, same area, because this rise amount should be covered by the same amount of fall afterwards. So যে কোনো একটা ফলের ইমিডিয়েট পরের যে রাইজ পয়েন্ট, সেই দুটো এরিয়া হবে ইকুয়াল, এই দুটো এরিয়া হবে ইকুয়াল। বাট সরি, আমি ভুল লিখছি না? হ্যাঁ, ভুল লিখছি, মাই ব্যাড। এই দুটো এরিয়া হবে ইকুয়াল, রাইজের ইমিডিয়েট পরের ফলটা হবে ইকুয়াল, রাইজের ইমিডিয়েট পরের ফলটা হবে ইকুয়াল। হাউএভার ফলের পরের রাইজটা হবে এরিয়াতে ছোট, because the height gain would be somewhat less. So what is the way we describe the energies over here is that when the ball is falling, Gp converts to K. In the process of compression and decompression, K converts to, I mean, the equation I can write, K converts to EP plus heat plus sound. If you wonder, sound cannot be always here. Well, sound is actually produced because of vibration. The sound can be infrasonic for some case. For example, if you bounce a rubber ball, you might not actually hear that sound because it's very fluffy and squishy. But some sort of vibration does happen on the surface. So this is the process that happens for the compression thing. And when it is decompressing, then the same thing happens. EP converts to Ke, and once again we have some heat and sound produced. So heat and sounds will be produced by default for any realistic scenario for an inelastic collision. And after that, you have a less amount of Ke remaining compared to the initial Ke that the ball hit with the ground, and that will be once again start to convert going to Gp once the ball starts to rise. So that's basically how this graph is going to look like. Now, the key part that Hassan asked, that how would this line look like in terms of acceleration? Well, traditionally speaking, the duration of movement through air, either rise or fall or both, is usually significantly larger compared to the duration of collision with the ground. So in many cases the bouncing ball graphs are drawn with vertical lines in between. For example, bouncing ball graphs might actually be represented like that, where the collision with the ground is represented with a visibly vertical line. What you need to understand, that it is represented as a vertical line because the amount of time it takes is extremely small. But if we zoom out on the graph, this line logically and realistically cannot be vertical, because a vertical line would practically mean a truly vertical line on the VT graph would mean infinite acceleration. You cannot have that. Infinite acceleration is an impossible thing. I don't know about what happens inside the black hole, but for a regular scenario, you cannot have infinite acceleration. So that's why this line would have some slant, but that slant would be very, very steep, like super steep. So for practical purposes, in many questions, you might see this to be a vertical line. This is drawn to be a vertical line for the sake of understanding or transferring the information that the collision duration is extremely small compared to the flight time. This idea or this approximation is also somewhat similar to the concept that whenever we learn the graph of the parachutist in the O levels, the VT graph for a parachutist actually looks somewhat like this. We're trying to do it like that. For a small segment of initial fall, we do it to be a bit of a straight line. For the way we describe this is that for that part, we consider the air resistance to be absolutely negligible. But that's not actually true. The person is falling through air. It is his motion is moving air particles. Air resistance cannot be zero. It might be small, but cannot be zero. But we represent it to a straight line just to give the students a concept that if air resistance was actually negligible, I mean, if the person was actually falling through vacuum, this is how the graph should have looked like. I mean, we want to bring about that information inclusive within the graph. That's why we prefer to draw one bit of a straight line at the beginning. But if you wonder in true scenario that even if the parachutist move one air molecule, air resistance is there. The magnitude of the force might be small, but it is not essentially zero because Newton's third law works. So that's the idea of approximation, that graphs which appear to be straight, should they be straight or not? That you need to ask yourselves. Then again, for these lines to be straight, our consideration is that we are considering the air resistance to be negligible. If air resistance was considered to be significant, then we should have a different case. I mean, we should have large acceleration at the beginning and less acceleration on the end, because the faster the object is going to start to move, its weight is going to be very much the same, but the opposing air resistance is going to become very, very high. So this straight line, if you consider air resistance as a significant force, this part should look like that. So initially you have a large acceleration, large speeding up, more gradient, and as the object speeds up, as it falls downwards, it's not accelerating as much. It's still accelerating, but not as much, so you're losing gradient. So these are the variations that you can have. Hassan, I think that answers your question.
Yes, sir.
আচ্ছা, হ্যাঁ বলো আব্দুল্লাহ।
একটা বাউন্সিং স্প্রিং এর গ্রাফ কেমন হবে?
Bouncing spring on its own?
Yes, হ্যাঁ স্যার, একবার টান মেরে ছেড়ে দিলাম ওরকম।
With a heavy mass at the bottom?
Yes, sir.
I mean, let me try to understand. How is the spring starting case? I mean, let's say, is it a spring that you are holding in your hand and dropping it on the ground like that, or is it a spring that is hanging from a solid support point and then you are pulling it down?
Has একটা ম্যাথ আছে নিচে।
So
MCQ number 55 আর কি 2.4 এই জন্য একটা কোশ্চেন ছিল।
I'll help, no problem. এইটা আচ্ছা,
yes sir, yes
এটা না?
yes sir.
এইটা অ্যাকচুয়ালি করা খুব সিম্পল। এটা কেন করা সিম্পল আমি বলতেছি। এটা করার অনেকগুলো ডিফারেন্ট উপায় আছে। আমি সবচেয়ে সহজ উপায়টা বলি। তোমরা তো ডিফারেন্সিয়েশন পড়ছো না?
Yes sir.
সবাই পড়ছো?
Yes sir.
সো তোমরা এটা এসে জানো যে dy dx of sin x হচ্ছে sin x হচ্ছে cos x, আর dy dx of cos x হচ্ছে minus sin x. And it can also work vice versa as well. মানে minus cos x হইলে হবে হচ্ছে sin x and so on and so forth. And these are the two key equation. এই দুটো ইকুয়েশন বুঝলে এই ধরনের গ্রাফগুলো কাজ করা অনেক সহজ হবে। কেন সহজ হবে বলতেছি, দেখো এখানে গ্রাফ দেওয়া আছে কি ডিসটেন্স ভার্সেস টাইম। তাহলে এই গ্রাফের যে শেপ বা এই গ্রাফের ডিফাইনিং রেশিও যেটা হবে সেটাকে ডিফারেন্সিয়েট করলে আমরা ভেলোসিটি গ্রাফ পাবো। তাহলে তুমি দেখো এটা হচ্ছে একটা মাইনাস কস কার্ভ। ক্যান এভরিবডি সি দিস ইজ আ মাইনাস কস কার্ভ?
Yes sir.
Yes sir.
And তুমি যদি dy dt of minus cos t করো তাহলে ইকুয়েশন তোমার কি দেয়? cos কে ডিফারেন্স করলে sin আসার কথা, মাইনাস sin আসার কথা, আবার সামনে একটা ডিফল্ট মাইনাস sin আসছে, তার মানে হচ্ছে মাইনাস মাইনাস মিলে প্লাস হবে, সো ইউ আলটিমেটলি গেট sin t। তার মানে আমাদের ভেলোসিটি গ্রাফ হবে একটা পারফেক্ট সাইন কার্ভ। বুঝতেছো?
Yes sir, বুঝছি।
এটা হচ্ছে সিম্পল ওয়ে। এছাড়াও আমি যদি গ্রেডিয়েন্ট ডিসকাশন করতে যাই, গ্রেডিয়েন্ট ডিসকাশন করে আমি তোমাকে বলতে পারবো, সেটা হচ্ছে হ্যাভ আ লুক এট দ্য গ্রেডিয়েন্ট ডিসকাশন। হোয়াট ইউ নিড টু সি ওভার হিয়ার, হ্যাভ আ লুক, দিস ইজ দ্য ডিসটেন্স গ্রাফ, দিস ইজ দ্য ভেলোসিটি গ্রাফ, হুইচ মিন্স এই গ্রাফের গ্রেডিয়েন্ট এখানে প্লট হইতে হবে। দ্য গ্রেডিয়েন্ট অফ দিস গ্রাফ will be the y-axis value of this graph, all of these graphs. First thing first. So first thing that I can go is that at the initial point we can see there is a horizontal tangent, so it's a zero gradient starting from zero velocity, so I can cross out b হবে না because b এর কারেন্ট আনসার শুরু হচ্ছে the positive velocity থেকে। Then if you observe from this point to this point, you can see that the gradient is slowly increasing. This is an increasing gradient curve, which means from your zero, the velocity should increase. You are having increasing velocity for A, C, for A and D, these two, because you should see that if I go along this dotted time frame instance, this part of the graph is showing velocity increasing and decreasing both. But this part of the DT graph showing you only increasing velocity, which means now C is out of the question. বুঝা যাচ্ছে কিনা?
Yes, sir.
Observing the gradient and trying to plot that reasonably within the answer choices. Then if you look at the next part of the graph, if you go up for the next segment, you should see that this is the maximum value of maximum gradient of your graph. So this is here the steepest point, and then you are losing gradient once again. And that is represented over here properly. You have the maximum value of velocity over here, and then you're losing gradient. And that is not represented over here as well, because well, I could actually discard D from the first segment as well. But you can see over in D option, it shows that our velocity is increasing, and it is always increasing, and it is increasing just like that. Now you couldn't. I'll tell you why you couldn't. I mean, observing the shape helps us to judge that. But what you need to see, that this part of the graph shows you velocity increasing because gradient increasing. So here velocity is seen to be increased. How the velocity is increasing is not included over here. All that you can decipher from here is the velocity increases, because you don't have values over here. I mean, what I'm trying to mean, you can, observing a DT graph, you can say whether the object is speeding up or slowing down. But you cannot say just by observing the DT graph without calculation. Without calculation, you cannot say from the observing a DT graph whether the object is accelerating, acceleration is increasing or decreasing. এটা বলা যাবে না। এটা বলতে পারতে হলে the VT graph plotted থাকতে হবে, অথবা আমাদের DT graph থেকে ইন্ডিভিজুয়াল পার্টের ভ্যালু নিয়ে আস্তে আস্তে ক্যালকুলেশন করে ট্রায়াল এন্ড এরর করে জাজ করতে হবে। So observing a VT graph, you can talk about what is happening to the velocity. So you can say whether the velocity increasing or decreasing, or in other words, you can say whether there is acceleration or deceleration. But whether the acceleration is increasing or decreasing, you cannot say that. So that's why this part of the graph actually shows us what? I mean, this curve that shows that for this much part we had increasing acceleration, for this part we have decreasing acceleration, both of which might be true. We don't know. So I'm gonna still keep this within my option. What happens over this part, we can see that the velocity decreasing, which is followed here and here equally, perfectly okay. If you now start to observe for this part, you can see that beyond this line, the gradient of this graph starts to become negative. Do you see that? Here you have zero gradient, and then you have negative gradient. তার মানে হচ্ছে আমাদের VT গ্রাফটা এখন আমাদের x axis এর নিচে চলে যেতে হবে। দেখো, if you have a look at D, for this D option, the velocity is once again increasing on the positive side, but only in option choice A, the velocity is going on the negative side. Ultimately, D is also crossed out. You're only left about choice is A, and A is the correct answer. এটা হচ্ছে ফিজিক্যালি অবজার্ভ করতে চাইলে তুমি এভাবে অবজার্ভ করতে পারো, বাট ইজিয়ার ওয়ে, ফাস্টার ওয়ে টু go for is always this thing. There is another thing that I might also include for this discussion, which is that what if you are given an acceleration time graph and you have to come up with a velocity time graph? For example, let's say we have the same question. I'm just messing with your brain because I want you to try this and struggle, because through struggle you can learn. It's very important. Let's say the question is exactly same, only over here they wrote acceleration. Now what should be your correct response? It's possible that the correct answer is not even there. If that's the case, you can tell me. Correct answer not given in the option, because I don't know whether the correct answer is there. I just came up with this idea. Maybe I'll help you a little bit. Acceleration of VDT gives you, so integration of VDT gives you distance. Integration of ADT gives you change of velocity. If you give limits over here, you can get the final velocity. Why am I trying to tell you? Is that if you integrate sin x dx, what do you get? You get minus cos x. Do you know that? তোমাকে ইন্টিগ্রেশন পড়ছো?
Yes, sir.
জি স্যার।
এটা চিনো সবাই, এই ইকুয়েশন চিনো সবাই?
Yes sir, yes sir.
জি স্যার।
আর if you
স্যার
integrate,
একটা কোশ্চেন স্যার।
হ্যাঁ বলো।
স্যার cos x কে ইন্টিগ্রেট করলে মাইনাস sin x না? না না মাইনাস sin x হবে না, cos x কে sin x হবে।
cos কে ইন্টিগ্রেট করলে শুধু sin x আসে, sin x কে ইন্টিগ্রেট করলে মাইনাস cos x আসে।
জি স্যার ওইটাই।
এটা মনে রাখা সহজ বুদ্ধি হচ্ছে যে ওই জাস্ট লেফট এন্ড রাইট চেঞ্জ। এনিওয়ে ডিফারেন্ট পিপল হ্যাভ ডিফারেন্ট ওয়ে টু রিমেম্বার দিস থিং। ইট অল ডিপেন্ডস অন ইওর টিচার এন্ড ইওর ক্যাপাবিলিটি টু গ্রাস্প ইনফরমেশন অ্যাজ ওয়েল। আমি ওই দিকে যাচ্ছি না যে কেন এটা মনে রাখবা। ইফ ইউ রিমেম্বার দিস থিং, দিস ক্যান হেল্প ইউ। ইফ ইউ ওয়ান্ডার যে এটা কেন আনতেছে, বিকজ এখানে আমরা অ্যাক্সেলারেশন থেকে ভেলোসিটি আসতে যাচ্ছি। অ্যাক্সেলারেশন কে ইন্টিগ্রেট করলে ভেলোসিটি আসবে। এখন তুমি এখানে দেখো আমাদের গিভেন কাজটা হচ্ছে মাইনাস কস কার্ভ। সো আমাদের এই কাজটা করা লাগবে। এখন আমি যদি মাইনাস কস কার্ভ কে ইন্টিগ্রেট করি তাহলে কি পাওয়ার কথা? নেসেসারি মাইনাস সাইন গ্রাফ পাওয়ার কথা না?
Yes sir.
আর মাইনাস সাইন গ্রাফ এখানে আছে কিনা?
নাই তো sir.
নাই তো। তার মানে এখানে কারেক্ট আনসার নাই। কারেক্ট আনসারটা হইতে হইলে কারেক্ট আনসারটা আমাদের এরকম হওয়া লাগতো, এরকম হওয়া লাগতো, উইথ দ্য টাইম ইনস্ট্যান্সেস পারফেক্টলি ম্যাচিং আপ। বুঝতেছো?
Yes sir.
সো এই জাজমেন্ট গুলো করতে পারলে তোমাদের এইরকম মানে পিরিয়ডিক মুভমেন্ট গুলো অনেক ইজিয়ার হবে। এটা নিয়ে আরো ডিটেলসে আমাদের এটুতে সিম্পল হারমোনিক মোশন নামে একটা চ্যাপ্টার আছে, ওখানে আরো ডিটেলস আমরা দেখি, ওখানে এই জিনিসগুলো আরো ভিভিডলি ইউজ করতে হয়। বাট ইটস এ গুড কোশ্চেন দ্যাট ইউ পিকড, বাট আই থিংক ইট মেড সেন্স। বুঝে গেছে ক্লিয়ারলি? হ্যাঁ বলো।
Yes sir. স্যার নাম্বার 2C তে একটু যাওয়া যাবে? 2C 1 এ?
পেপার 2
হ্যাঁ স্যার, পেপার 2।
দেখতেছি, দাঁড়াও। 2C1 calculate the kinetic energy of the pellet just before the impact. Sorry, calculate the kinetic energy of the bullet just before the impact. হ্যাঁ
স্যার 2 আপনি 1 এ আছেন।
সরি। টু সি টু এটা না 1C2?
না 2C1 স্যার, 2C1।
2C1 এটা।
এই যে চেঞ্জিং মোমেন্টাম, ইয়েস স্যার। সেখানে মার্স স্কিমে মানে স্যার আমি এখন আই এম নট গেটিং ইট স্যার। ভেলোসিটি আমরা দুইটা অ্যাড করে দিচ্ছি কেন চেঞ্জিং মোমেন্টামের জন্য? লাইক সাইনটা আমার প্রবলেম হচ্ছে।
আচ্ছা, I'll help you, no don't
যে
worry.
মার্স স্কিমটা একবার
আমারও বাকি সব কোয়েশ্চেনে প্লাস করা হলো।
আচ্ছা
প্লাস দেওয়া হয়।
বলতেছি আমি কেন প্লাস করতেছে, বলতেছি আমি তোমাদেরকে প্লাসটা কেন দিছে এবং প্লাসটা দিয়ে তারা অ্যাকচুয়ালি কি মিন করতেছে দুটাই বলতেছি। একটু দাঁড়াও, I'll make it easier for you. Try to have a look over here. আমাদের এখানে গ্রাফের এই ভ্যালুগুলো হচ্ছে এই পর্যন্ত ভ্যালুগুলো ভেলোসিটি হচ্ছে পজিটিভ, এরপর ভ্যালুগুলো হচ্ছে নেগেটিভ। কোশ্চেন বলছে ক্যালকুলেট ফর দ্য ফার্স্ট 3.5 সেকেন্ড অফ মোশন অফ দ্য স্ফিয়ার দ্য চেঞ্জ ইন মোমেন্টাম অফ দ্য স্ফিয়ার। তো আমাদের নরমালি ইকুয়েশন কি হওয়ার কথা? m = v - u। ঠিক আছে, এখানে ম্যাথ দেওয়া আছে 0.78 টাইমস 0.78 বসাবো। আমার ভেলোসিটি আফটার 3.5 সেকেন্ড, 3.5 সেকেন্ড হচ্ছে এখানে, 3.5 সেকেন্ড পর ভেলোসিটি হচ্ছে এই জায়গায়। এই পয়েন্টটাকে যদি আমি জুম আউট করি, দিস পয়েন্ট শুড বি, এটা হচ্ছে
4.2।
দাঁড়াও 4 পয়েন্ট, I'd say 4.25।
মার্স স্কিমে ওকে স্যার।
মানে 4 আর 4.5 এর মাঝখানে কোথাও কাট করছে, তাই তো?
ইয়েস স্যার, হ্যাঁ স্যার।
4 আর 4.5 এর মাঝখানে কোথাও কাট করছে। সো লেটস সে আই এম কনসিডারিং দিস টু বি -4.25। এটা হচ্ছে আমার ভ্যালুর মাইনাস, আর এরপর হচ্ছে ইকুয়েশনের মাইনাস, আর ইনিশিয়াল ভেলোসিটি হচ্ছে আমার পুরোপুরি +9। এই যে এটা হচ্ছে আমার সরি 5 6 7 8 9, হ্যাঁ +9। এটা হচ্ছে আমার ইনিশিয়াল ভেলোসিটি। সো এখানে আমি বসাই না। এখন জিনিসটা খেয়াল করো, আলটিমেটলি আমার ম্যাথমেটিক্যাল অপারেশনটা কি হবে? আমি এই দুটো নাম্বারকে আলটিমেটলি অ্যাড করে একটা ভ্যালু পাবো না? মানে আমি যদি 0.7 টাকে রাখি এই পর্যন্ত, আলটিমেটলি তুমি ক্যালকুলেটরে বসে এটা কি আসবে? -13.25 আসবে, ঠিক না?
ইয়েস স্যার।
তো প্রাইমারি ম্যাথমেটিক্যাল অপারেশনটা কি হচ্ছে? ভ্যালু দুটো অ্যাড হচ্ছে, কারণ একটার সাইন বাই ভার্চু মাইনাস, আর ম্যাথমেটিক্যাল অপারেশন করতেছি আমরা মাইনাস, ঠিক কিনা?
ইয়েস স্যার, ইয়েস স্যার।
মার্স স্কিমে ওই জিনিসটাই ওরা রেফার করছে। মার্স স্কিমটা আমি বের করি, দেখাই। এটা হচ্ছে 2C1, তাই না? এই যে চেঞ্জ অফ মোমেন্টাম হচ্ছে 0.78 9.0 প্লাস 4.2, allow 4.2 plus minus 0.2 or 10.3 Newton second, allow 10 Newton second. ওরা এখানে প্লাস দেখানোর বেসিক মিনিংটা হচ্ছে যে ওরা চেঞ্জ অফ মোমেন্টামটাকে ইনিশিয়াল মাইনাস ফাইনাল হয়তো করছে। তোমরা ডেফিনেটলি এটা ফাইনাল মাইনাস ইনিশিয়াল করবে। ডেল্টা ভি শুড বি ডেল্টা ভি চেঞ্জ অফ সামথিং অলওয়েজ মিন্স ফাইনাল মাইনাস ইনিশিয়াল অলওয়েজ। So the reason they have given plus over here to represent that the ultimate mathematical operation should be addition of those two values. তোমার ক্যালকুলেশনে বা আমি যদি ক্যালকুলেশনটা করতাম, আমার ক্যালকুলেশনে এই আনসারটা আসতো মাইনাস। সো আমি এখানে আনসারটা কিভাবে লিখতাম? আমি আনসারটা লিখতাম হচ্ছে এইভাবে, আর give the minus sign within bracket and then give the correct magnitude over here. This is the safest way to incorporate minus sign in your final answer in any question all the way up to A2. এটা হয়তো আমি তোমাদেরকে ও লেভেলস হতে বলে থাকতে পারি, না বলে থাকলে এখন শিখো যে if you have a minus sign in your answer that you are not so sure whether you should include or not, write the minus sign within bracket. It's a valid and acceptable way. The benefit is that if the examiners are looking for a minus sign, it's there, they should give you the mark. If the examiners are not looking for a minus sign, there is a bracket around, so they can choose to discard it, and it works both way. বুঝছো কি বলছি?
Yes sir.
প্রজন্ম বুঝা গেছে?
Yes, sir.
মানে মেইন ম্যাথমেটিক্যাল অপারেশনটা হবে দুইটা ম্যাগনিটিউড অ্যাডিশন হবে। এখন কেউ যদি মানে পজিটিভ মাইনাস মাইনাস করে তাও অ্যাড হবে, আর কেউ যদি মাইনাস ভ্যালু মাইনাস পজিটিভ ভ্যালু করে তাও আলটিমেট ম্যাথমেটিক্যাল অপারেশনটা হবে ওই দুইটা ম্যাগনিটিউডের অ্যাডিশন। ওই জিনিসটাকে সিগনিফাই করার জন্য ওরা প্লাস দেখাইছে। এখানে এক্সামিনেশন রিপোর্টটা যদি আমরা একটু দেখি, তাই it might actually give us a bit more insight for C1. The question part was generally completed successfully. However, candidates should be warned that when they're reading values from the graph, they should not read the nearest grid line. In this case, many quoted the final speed as 4 meters per second, when quite clearly the speed could be read to be more than one significant figure. So, এখানে গ্রাফ রিডিং নিয়ে তারা কিছু কোশ্চেন বলছে, এটা এক্স্যাক্টলি 4 পড়া ঠিক হয় নাই, 4 এর থেকে কিছু বেশি পড়া উচিত ছিল। তারপরে তারা 4 হইলেও তারা এটাকে অ্যালাউ করছে, অ্যালাউ 10.10 নিউটন সেকেন্ড হলেও তারা মার্কস দিছে, which is also okay, no big deal. 4.2 plus minus 0.2 they allowed to be taken as 0.4, sorry 4.0. That's their বদান্যতার ইংলিশ কি? কার্টিস। আচ্ছা, কোনখান থেকে যেন আমরা বাউন্সিং বলের গ্রাফে গেছিলাম? এখান থেকে গেছিলাম। আচ্ছা, এনিওয়ে এটা তো বুঝা গেছে, এখন বুঝা গেছে না ক্লিয়ারলি? হাসান তুমি মাঝখানে হাত উঠাইছিলা, তোমার কোশ্চেন আনসার পাইছো?
স্যার জি স্যার, ওটা ভুলে ছিল স্যার, মানে আমি পরে লোয়ার হ্যান্ড করতে ভুলে গেছিলাম।
ঠিক আছে, সমস্যা নেই।
স্যার এবার 7C2 তে যাওয়া যাবে?
হ্যাঁ 7C2 তে যাওয়া যাবে।
স্যার কোশ্চেন নাম্বার 4 টা স্যার একটু সলভ।
এই ডায়াগ্রামটা আঁকা তোমাদেরকে দেখাইছিলাম কি?
Yes sir.
জি স্যার, কম্পাস দিয়ে টানতে
টাকা
বলছিলেন।
কোশ্চেন নাম্বার 7
C না 7A2 স্যার, 7A।
আচ্ছা দেখতেছি, দাঁড়াও।
স্যার পরে 6E টাও একটু দেখাই দিও।
আচ্ছা ঠিক আছে, আমি বলছি একটা একটা করে বলতেছি, একটু একটু মনে রাখো অথবা মাথায় রাখো। দাঁড়াও, 7 কই? কোশ্চেন নাম্বার 7, হ্যাঁ দিস ইজ এ নাইস কোশ্চেন। এরিয়া অফ দ্য গ্রাফ।
হ্যাঁ স্যার, এরিয়াটাই বাইর করা আছে, কিভাবে করব স্যার?
স্যার এটা করে দিছিলেন স্যার।
আচ্ছা, মেবি দ্যাট ওয়াজ ওয়ান অফ দ্য সান রেজ। আচ্ছা আব্দুল্লাহ, তুমি আজকে ক্লাসের পর একটু থাকো, আমি তোমাকে এরিয়া ক্যালকুলেশন দেখাই দিব।
স্যার আমি এটা ইকুয়েশন বানিয়ে করেছিলাম।
ইকুয়েশন বানায় করলে পারফেক্টলি হবে, বাট তোমাকে ফুল মার্কস দিবে না, বিকজ দ্য এক্সামিনার্স অফ at least the physics examiners appreciate to attempt of square counting for area under the curves.
স্যার আমার আজকে 9:30 থেকে আরেকটা ক্লাস আছে, তাই আর কি।
আচ্ছা ঠিক আছে, তাহলে কালকে সকালে।
ঠিক আছে স্যার।
তুমি কখন ফ্রি থাকবা?
তাহলে আমি সারাদিন ফ্রি আছি স্যার।
তাহলে 9টার সময় আমাকে মেসেঞ্জারে কল দিও।
ঠিক আছে।
আচ্ছা এটা এরিয়া কেমন ক্যালকুলেশন করতে হয় সেটা তোমার আমি দেখাবো, ডোন্ট ওয়ারি। আচ্ছা একটা অভিক একটা কি প্রবলেম বলছো?
স্যার 6E2
6D2 এটা
E2
E2। আচ্ছা হ্যাঁ, এই জিনিসটা বলতেছিলাম। আচ্ছা এখানে একটা জিনিস দেখো, আমি একটু কোশ্চেনটা রাফ ওয়ার্কিংটা বলি। সেটা হচ্ছে the girl is throwing a ball vertically above, is rising up to a final height and eventually falling down on the sea surface or at the bottom of the cliff, whatever that is. So this is the rising height, this is the falling height. The difference of these two gives you the height of the cliff. আচ্ছা এটা খুব একটা ঝামেলা কোশ্চেন না, এই পর্যন্ত ঠিক আছে। এবার আমাদের কোশ্চেন বলছে state the principle of conservation of momentum. You just say that principle properly. You have 2 marks over here, 1 mark for mentioning the precondition, the second mark for the actual description of the rule. Number 2 is important. Number 2 says comment on your answer to D by reference to this principle. Now you are asked to make comment and there is 3 mark to it. How could you possibly score full 3 mark for a comment like this? Now try to understand this thing. Answer to D. What is found in option answer question number D? D said the ball has mass 250 gram. Calculate the magnitude of the change in momentum of the ball between the time that it leaves the girl's hand to time t equals to 4.0 second. So we are asked to find out the change of momentum from the initial to up to 4.0 second time. So what is happening to the momentum? So 4.0 second time, there is actually not all the way up to the end, is up to this much point. So there was a momentum change. Now try to understand this thing. From the instant the ball left the girl's hand to the point of before hitting the ground, all the way, or let's say up to 4.070 seconds, the ball was under the effect of a force. The name of that force is weight. The reason that force word is called gravitation. And the other object which was involved to create that force is called earth, which means for this rise and fall scenario of the ball, the 2 objects which interacted with each other, one of the object was ball, the other one was earth. They are the 2 objects pulling onto each other because of the force of gravitation, which means by Newton's third law, there should be equal and opposite force acting on each other, and the change of momentum should be equal for both of them and work in opposite direction, which means the change of momentum that you get for the ball over the duration of time, earth should have an equal and opposite direction of momentum change within that same amount of direction. Momentum change should be exactly same for both of them. Delta P1 equals to minus delta P2. There is absolutely no discrimination or exception of that. However, this momentum change for earth would cause imperceivable acceleration or imperceivable velocity change because the earth's mass is extremely large. If we divide the total momentum change that happened due to the throw of the ball divided by the mass of the earth, you might have some delta V, which might give you a very small number. You have to write a lot of zeros after the decimal point to get some actual non-zero numbers after that. So the momentum change of earth would be negligible, but it would definitely happen. By Newton's third law, by the law of conservation of linear momentum, the momentum change of earth would happen. How should you perceive these questions properly? What you need to ask yourself whenever you come across these kind of questions, what you need to ask yourselves, that we are having 2 objects interacting with each other for which there is a acceleration. So what are the 2 objects which are interacting with each other? For this case, one of the ball, the other one was earth. In other cases, it can be 2 different objects. For example, in other cases, it can be if you consider in space. Let's say if you consider in space, I'm just going to a different example. Let's say there is a rocket that is orbiting around the moon. Now it wants to come back to earth. So what does it have to do? It has to burn its thrusters to get out of the orbit and then slowly start moving towards the earth. So what is happening when the rocket starts to burn its thrusters or starts to fire its rocket engine? It starts to exhaust the burnt gases. So that mass leaves out from the rocket's back, and as a result, they have a momentum change. By Newton's third law, the rocket gets a forward momentum change. So within that system, if you consider that scenario, the closed system that is involved over there, one of them is the gas molecules, the other one is the rocket. So together they make the system, and who work on each other by Newton's third law. Here also the system is made up of 2 objects, one of which is the ball, and the other on is the earth, and together they're working on each other. So to score full 3 marks for this question, this is how I would write the answer. I might be wrong. I'm going to look at the mark scheme and I'm going to stand corrected if I'm wrong. I'm going to write the closed system over here is made up of the ball and the earth. That's the first statement that I'm going to write. I'm going to define my periphery of my observation. And then I'm going to write by Newton's third law, they both exert equal and opposite force on each other, and so by the law of conservation of linear momentum, they have equal and opposite change of momentum, which means as the ball experiences a momentum change downwards, Earth experiences equal amount of momentum change upwards. I said a lot of words. I might actually made it simpler by thinking within my head, but these are the three core information that I'm going to write. I'm going to first mention that what is my system. Then I'm going to mention by Newton's third law, they will experience same force by the expression of conservation of linear momentum. They will have same amount of momentum change. And then I would preferably describe what would be the momentum change of the Earth. Ball experiences the momentum change downwards. Earth should experience same. You might as well quote this number over here as well, that the change of momentum for the ball is this much downwards. So the change of momentum of Earth would be this much Newton second upwards. That can be the total elaborate answer. But does it make sense? বুঝা গেছে কিনা?
হ্যাঁ স্যার বুঝেছি।
মার্কিং একটু দেখি আমরা নাম্বার 6E2। Either the system is ball and Earth, momentum of Earth changes by the same amount but in the opposite direction, or ball is not an isolated system, so there is a force on the ball, gravitational force to act on the ball, cause change of momentum, but a law does not apply here. If external state of allow first mark only. Okay, my earnest request that don't go for the or explanation. Or explanation is logically acceptable under the reference that you consider the ball to be not an isolated system, that you consider that the ball is actually surrounded by air and Earth, and there can be moon's gravitational effect, there can be the sun's gravitational effect, and if you consider everything combined together and you just want to define the ball as not an isolated system, you can write that. But I'd highly appreciate that you don't adopt that explanation. Preferably write the either explanation. That is the more preferable to the examiners as far as I've seen, because that actually allows the examiners to understand that you could actually apply the concept of conservation of linear momentum for a certain given scenario, other than just declaring that it is not applicable. The mark scheme tells us logical comment was limited to a minority of answers. Two approaches were acceptable. First, the ball and the Earth could be identified as a closed system to which the principle could be applied. Second, it could be argued that the principle does not apply to the ball because it is not an isolated system. Many answers were inadequate in that they were not based on a full statement of the principle. A common answer to state that the principle does not apply because the ball is not suffering a collision. Okay, this was a very common mistake. Suffering a collision is not necessary. As long as two objects interact with each other under the effect of some force, Newton's third law apply, period. You don't have to have them within physical contact. You don't have to have that.
Sir, answer correct একবার বলতে পারবেন?
In my words?
Yes, sir.
I might actually write this way, that the closed system is made up with the ball and Earth, full stop. By Newton's third law, they exert equal and opposite force onto each other, semicolon. The change of momentum of either of them is equal and opposite of each other, full stop. This is going to be my second sentence. Might as well cover the whole part, but if possible, I might write one more sentence that ball experiences upward momentum change this much Newton second, semicolon. Earth experiences ball experiences downward momentum change of this much Newton second, full stop. Earth experiences upward momentum change of this much Newton second. I'm gonna write that. I'm gonna just put it all together clearly in there.
Sir, third line ta to second line tar je continuation na sir.
Exactly. It's just stating with using those numbers, because they have told us that by reference to D. Sorry, comment your answer to D. So I just wanted to include those numbers. If you want to skip that, you can also write it in this format, that the closed system is made up with the ball and the Earth. The ball experiences an upward momentum, downward momentum change of this much Newton second. By conservation by the law of conservation of linear momentum, Earth also experiences this much Newton second momentum change upwards. That could also work if you want to skip the part with the Newton's third law.
Yes, sir. The rate of change of momentum is equal and opposite to the ball and the Earth. Yes, sir.
Yes. তারপর
স্যার ডিরেকশন
নাম্বার 4 স্যার।
স্যার ডাইরেকশনটা না আমার কনফিউশন আছে।
হ্যাঁ বলো, ডাইরেকশনের কনফিউশন বলো।
স্যার এটা কি বলের জন্য ডাউনওয়ার্ডস হবে?
Well, that's what's the plausible scenario is showing us, because you can see that the ball is experiencing an acceleration downwards, right? Weight is working downwards. So if the ball is being pulled downwards, earth should be pulled by the ball upwards.
ইয়েস স্যার। আর স্যার যদি বাউন্স করে আবার উপরে উঠে যেত তখন?
Well, bounce করে যদি আবার উপরে উঠতো, then in the case for the duration of bounce, there would be a different scenario. For the duration of bounce, the earth would be pushing the ball upwards and the ball should be pushing the earth downwards. So I mean, so তখন আমাদের momentum change in direction for the duration of bounce, as long as the contact was there, we would have the opposite scenario, because in that case the outward forces would be bigger compared to the inward force. I mean, the collision force by magnitude logically should be somewhat bigger than the involved weight of the object. বুঝছো? তখন
Yes,
momentum for that duration, momentum change duration will be opposite, but the moment the ball completes the bounce and starts to go upwards once again, তখন আবার তাদের available force হয়ে যাবে inward towards each other.
ওকে স্যার।
বুঝা গেছে ক্লিয়ারলি?
স্যার
আচ্ছা, প্রজন্ম যেন কি এটা বলছ, প্রজন্ম না অভিক যেন কি একটা কোশ্চেন করতেছিলা না মনে হয়?
স্যার বলছিলাম স্যার কোশ্চেন নাম্বার 4 স্যার, ওই যে আমি বলছিলাম স্যার হাসান।
What happened to Aswad? He doesn't ask questions no more. Acha, anyway, if we have a look at the other parts, any further question, kids? Do you have?
স্যার নাম্বার 4 স্যার।
Number 4. Number 4 এর কোনটা বলো? আচ্ছা,
স্যার 4 এর বি পার্টটা স্যার।
4 এর বি। আচ্ছা, নাম্বার 4 রিলেটেড আরো একটা ভালো কোশ্চেন আছে, ওটা মনে হয় আমাদের ফোর্সেস চ্যাপ্টারে চলে গেছে মোমেন্টাম। আচ্ছা, ওটা ওই চ্যাপ্টার থেকে একটা বাই করে দেখাবো, নো ওয়ারিজ। আচ্ছা, কোশ্চেন নাম্বার 4টা একটু দেখি। কোশ্চেন নাম্বার 4 এ বলছে a ball of mass 1.2 kg is traveling at a constant velocity and collides head on with a stationary ball S of mass 3.6 kg as shown in figure 2.1. Frictional forces are negligible. The variation in time t of the velocity v of the ball before, during and after the colliding with the ball S is shown in figure 2.2. Okay, this shows us that the ball is undergoing collision, and you can see that the time scale over here is highly magnified. You can see that each 10 division is only covering 0.1 second. So the reason it is highly magnified, I'm defining it to be highly magnified, so that the collision process can be shown with a significantly slanted line. If it was plotted in second, I mean, let's say if every division was second, then this would actually appear to be a vertical line. That's what I talked about a bit earlier. Okay, we have this graph. As we can see that the collision starts at around 0.18 seconds. The collision lasts up to 0.26 seconds. And within this part, the positive velocity 4 meter per second changes to minus 0.8 meter per second, which means the ball B bounces backwards. That's the information that is given on the graph. B number says use figure 2.2 to determine for the ball B during the collision ball changing momentum of the ball B. So changing momentum once again here, the final velocity was negative, the initial velocity was positive. So ultimately the mathematical operation should be addition. In the mark scheme it shows plus, because these two numbers 0.8 and 4.0, by some mathematical calculation they should be added. You can either write 4.0 plus 0.8, acceptable, or you have to write minus 0.8 minus 4.0, which also gives you minus 4.8, also acceptable. I think that was the point of question, right? The add করছে কেন দুইটা নাম্বার?
Yes স্যার, একটু রিলেটেড ছিল স্যার।
The magnitude of the force acting on the ball, that is basically simple. You just find out the rate of change of momentum divided by time. That gives you that value. If you have a look over here, take a very good look at the scale and read the numbers carefully. এখানে নাম্বার রিড অফ ভুল করার জন্য যদি তোমাদের আনসার ভুল আসে, you're gonna lose 2 marks actually. You're gonna lose mark, and you're also gonna lose the read of mark. So you might only get 1 mark because there's a 3 mark over here. সেটা হচ্ছে যে তুমি ইকুয়েশন কারেক্ট লিখছো, ওটার জন্য হয়তো 1 মার্ক পাইতে পারো, পার্শিয়াল মার্কিং বলো।
স্যার ওর অ্যান্সার যদি অ্যান্সার 2dp পর্যন্ত ভ্যারি করে মার্কস তো দিবে স্যার, তাই না? জাস্ট ইন কেস।
বলতেছি তুমি তোমার আনসার 3SF এ লিখবা preferably. I mean, if I was answering any of AS paper or A2 papers or O level paper for all I care, I would preferably give all of my answers in 3SF. If the mark scheme does have an answer that is not in 3SF but in 2SF, then you should see if you round up your 3SF answer into 2SF, whether that number perfectly matches with the mark scheme number. If it does, move on. If it doesn't, look further into it or ask me about it. It's not about
জি
DP.
স্যার।
আচ্ছা, এখানে আমি আরেকটা কোশ্চেন যেটা দেখা যাচ্ছে সেটা সম্ভবত আমাদের এই ওয়ার্কশিটে নাই। দাঁড়াও, আমি একটা ড্রয়িং এর একটা কোশ্চেন আছে, ওই ড্রয়িং এর কোশ্চেনটা দেখে আমি তোমাদেরকে দেখাবো। এটা সম্ভবত ফোর্সের চ্যাপ্টারে চলে গেছে। দাঁড়াও, ওখান থেকে দেখাচ্ছি, ডোন্ট ওয়ারি। ইজ দিস দ্য ওয়ার্কশিট?
স্যার আমরা কি ডাইনামিক্স শেষ করছি, লাইক এটা নাকি ফোর্সেস করব আবার?
No, that's more or less done. For the discussion part, that's more or less done. আচ্ছা হ্যাঁ, এই যে এখানে একটা কোশ্চেন ছিল। This from the force worksheet, which might be in some later page of your worksheet. If you have the booklet in your hand, which you should have had, please turn up to on the page number 7 of the forces and moment P2 worksheet. Have a look at question number 8. Please jump there. এটা তোমাদের কমান্ড ওয়ার্কশিটের পেজ নাম্বার কত আমি বলতে পারতেছি না। Can someone help me on that?
স্যার পেজ নাম্বার 7 অফ 21।
আইসো সবাই, এই কোশ্চেন নাম্বার 8টা একটু সবাই অ্যাটেম্প করো, তোমাদের অ্যাকচুয়াল ওয়ার্কশিটে একটু অ্যাটেম্প করো। এটা এখানে প্রথম পার্টটা খুব সিম্পল, যে টু ডিফাইন ফোর্স, টেকনিক্যাল সার্ল অফ মোশন, because there is a 3 mark over here. Before you look into the marks, you have to think that what could possibly be for a worthy of 3 mark answer for Newton's third law of motion. Try to think about it, write about that, then attempt these questions. And the important part for which I'm interested in this question is for the completion of this graph. Attempt this graph as well. I'll leave you with for 5 minutes. I'll be back after 5 minutes. Sorry, I forgot to resume the recording. Okay, my bad. Oh, so we just started the recording. The graph for that question should be looked like this. We have equal and opposite momentum changes. So we dropped the sphere, we counted the sphere A momentum dropped by 18 division. So we have to increase the sphere B momentum by 18 division over the same amount of time. That's the key idea for this graph. I just repeated that because I wanted that to be within the recording. That's why. Thank you. Thanks for reminding me. I make sure ভুলে গেছিলাম recording on করতে হবে. My bad.
স্যার কোশ্চেন নাম্বার 10 স্যার।
Question number 10. Let's have a look. Question number 10. হ্যাঁ বলো। Francium 208 is radioactive and emits alpha particles the kinetic energy of this mass to form a nucleus of asteroid as resistance period 3.1. Still the nature of alpha particle. আচ্ছা, এটা একটা weird question. What do you mention for the nature of an alpha particle? You can write a lot of things. I would write it's the helium nucleus with plus 2e charge and 4u mass. I would write everything, but in the mark scheme I think they have only given it's the helium nucleus. That should be okay for a 1 mark question. Acha, one thing that I should
চার্জ দিব
না 2e, আমি একটা জিনিস এই পার্টটা একটু আলাপ করি, সেটা হচ্ছে one of the key thing that you need to understand. If a certain atom is written like this, let's say sodium 11. Sodium 11 atom means the nucleus and also the electrons. The mass of one sodium 11 atom is 11u. Sometimes considering the mass of the electrons to be negligible, if we do consider that, sometimes this word atom might also be replaced with the word nucleus. But you should know that 11u is the total mass of the whole atom, which means the proton neutron in the nucleus plus the electrons that we have on the outskirts as well. U is the atomic mass unit, which is basically 1/12 of carbon 12 atom isotope. এটার অ্যাকচুয়াল কেজি ভ্যালু আমাদের ওয়ার্কশিটে ফর্মুলা শিটে দেওয়া থাকবে, that value in kg would be given to us, so you don't have to memorize that, but you have to understand that this is one of the way we can mention atomic level masses because they are usually pretty small. That's one thing. The other thing that is important, that in chemistry in many cases we write that the charge of a sodium ion is +1. +1 what? I mean, charge is a measurable quantity, so does it mean +1 coulomb? The answer is no. +1 in this case actually represent, it is 1 time the amount of elementary charge. Elementary charge basically mean, the word elementary charge means the smallest fraction of charge that we can observe other than subatomic cases. Quarks can have fractions of that, but if we consider regular objects for non divided protons, the amount of charge, or I can say the HCF of multiple charge objects, the HCF of multiple charge objects is basically the charge of one electron. So that is usually represented as elementary charge E, which has a value of 1.602 in 10 to the power minus 19 coulomb. That's the value of elementary charge. One electron has a charge of -1 e, one proton has a charge of +1 e, and neutrons have 0 charge. So a helium nucleus will have a charge, a helium nucleus, helium-24 nucleus will have a charge of +2e. E in this case means elementary charge. So this is a allowed symbol. You can write this symbol for short values. You don't have to write this thing in the full number. But if you want to be on the safe side, in many cases, you can also mention this as the total charge of a helium nucleus is +2 into 1.6 into 10 to the power minus 19 coulomb. That's also perfectly acceptable, no big deal. Or you can write +2e, where e is the elementary charge. That's also okay. Why am I telling you this? Because right after this question, we are going to come across the consideration for the decay process. So if you have a look over here, it says francium 208 is a radioactive nuclei and emits an alpha particle with the kinetic energy of this mass joule to form a nuclei of astatine as illustrated in figure 3.1. So show that the initial speed of the alpha particle after the decay of a francium nucleus is approximately this much meter per second. How do we get this math? So you have to understand that helium nucleus has a mass of 4u, and you can get the u value from your value sheet, which is about 1.66 into 10 to the power minus 27 kg. I think that's correct. I'm gonna have a look. Any year question should have that value, so doesn't matter where I go. Any QP.
স্যার ওই নেচারের সাথে মানে এটাই 1.66 into 10 to the power minus 27 মাল্টিপ্লাই করতে হবে।
If you want to mention the charge, have a look. এটা হচ্ছে elementary chargeর value. এটা তোমাদের এই you'll be provided with this data booklet in your exam, all of them. Elementary charge is this much. An unified atomic mass constant, which is called AMU, atomic mass unit, or unified atomic mass constant, however you say, that is 1.66 into 10 to the power minus 27 kg.
স্যার এবার বুঝছি স্যার, আমি মাল্টিপ্লাইটা করি নাই স্যার, I was confused. স্যার সাইমালটেনিয়াস ইকুয়েশন বানাইতে হবে স্যার।
না, সাইমালটেনিয়াস ইকুয়েশন এখানে লাগবে না, বাট মোমেন্টাম ক্যালকুলেশনের সময় আমাদের ওই ভ্যালুটা না বসালেও হবে, কারণ মোমেন্টাম ক্যালকুলেশনের সময় ইউ বোথ সাইড থেকে কাটা যাবে, সেটা আমি একটু দেখাবো। ডোন্ট ওয়ারি ফর দ্যাট। সো এখানে ম্যাথ আমরা এতটুকু বের করলাম, সো এটার সাথে আবার 4 মাল্টিপ্লাই করা লাগবে, 4 into this much, আমি 4টা লিখতে আগে ভুলে গেছিলাম, মাই ব্যাড। And then you have the kinetic energy given, so simply express that kinetic energy as half mv square. এখান থেকে ভ্যালু বসাবো, v এর ভ্যালুটা বাই করলে অ্যাপ্রক্সিমেটলি এই ভ্যালুটা আসবে, which is not a big deal provided you know how to deal with the mass. এরপরে কোশ্চেনে বলছে state the principle of conservation of linear momentum. You just mentioned that, 2 marks, one for precondition, another one for the statement. Number 2 says the francium 208 nucleus is stationary before the decay. Estimate the speed of the astatine nucleus immediately after the decay. Important bit. So what is happening over here? Before the collision, before the breakdown, the total momentum of the combined object was 0. So I can write 0 over here. And after the collision, we are asked to find out the speed of the astatine nucleus. So I can write for the helium nucleus, this is 4.8 u multiplied by 1.8 into 10 to the power 7. I think that was the number, right? Yes. plus the remaining thing, what should be the mass of the asteroid nucleus. Now that's the part that you have to understand from the concept of from the nuclear physics. Francium had 208. This is the mass number for francium. So whenever an alpha particle leaves from it, what should be the mass number of asteroid nucleus?
Sir, 204.
Beautiful. সবাইকে বুঝছো যে 204 কেন হবে? The reduction of the mass number 204 multiplied by some value. Let's say I'm gonna write v. So basically এখান থেকে তুমি v টা বের করবা, এখানে তোমার ভ্যালুটা মাইনাস আসবে, এই ইকুয়েশন থেকে ভ্যালুটা মাইনাস আসবে because that will be velocity, because this should be obviously in the opposite direction of this thing. But finally তুমি যখন স্পিড লিখতেছো এখানে জাস্ট ম্যাগনিটিউডটা লিখবা because they asked for the speed, didn't ask for direction. So that's okay. এখানে আমি 204 এর পর অবশ্যই u লেখা উচিত ছিল, আমি ইউটা লিখতে ভুলে গেছি, so it was my bad. Might as well rub this off a little bit. 204 u multiplied by the speed that we are trying to calculate. So এখানে u টা automatically both sides cancel out হয়ে যাবে because you can divide both sides by u very easily. So you don't have to bother to write the whole value of u over here. Not needed because u can be cancelled out. But for this expression, you have to provide the value of u in terms of kg. That's important.
Sir,
নাম্বারটা হচ্ছে একটা খুব ইম্পর্টেন্ট কোশ্চেন, বলো।
স্যার ফ্রান্সিয়াম অ্যাটমটা স্যার যে ডিকে করবে ওটা তো আগে স্টেশনারি ছিল স্যার, তো ইট হ্যাজ আ জিরো মোমেন্টাম। পরে যে অ্যাস্টাটিন আর হিলিয়াম ফর্ম করবে ওই দুইটার মোমেন্টাম দুইটাকে ক্যান্সেল আউট করে জিরো করবে। দ্যাটস ওয়াই উই কনসিডারড ইট জিরো, রাইট স্যার? যে দুইটার মোমেন্টাম অ্যাড করে জিরো লিখছি।
Precisely. This is the total momentum of the system before the breakdown. This is the total momentum of the system after the breakdown. So I mean m1 u1 plus m2 u2 পুরো জিনিসটাকে ভেঙে না লিখে just perfectly zero লিখে দিয়েছি because the common particle was initially at rest as per the question. আচ্ছা, D number questionটা দেখায়। D number question বলছে close examination of the decay of francium nucleus indicates that the asteroid nucleus and the alpha particle are not ejected exactly in opposite directions. Try to understand this thing very, very carefully. Close examination of the decay of francium nucleus indicates that the asteroid nucleus and the alpha particle are not ejected exactly in the opposite directions. Suggest an explanation for this observation. Achha, etar logical explanation hoche there must be a third particle involved within this breakdown, which should move in a direction other than the direction of astatine or alpha nucleus. Now let me tell you what this actually means. I mean, to eke dekhachi. Try to understand this thing. Let's say this was our francium nucleus of mass number 208. This breakdown, if it exclusively broke down into two particles, let's say helium nucleus, helium 4, and let's say there is the asteroid nucleus 204. If it broke down into exactly two particles, then their momentum should be in exactly opposite direction. The reason they have to be in exact opposite direction, because you have to understand the equation that we write for the conservation of linear momentum, m1 u1 plus m2 u2 should be equals to m1 v1 plus m2 v2. Here, all of these variables u1, u2, v1, and v2, they are vector quantities. Because we define this thing as a conservation of linear momentum, we often don't show the vector signs, but they're all vector quantities. That's the reason we have to incorporate the plus or minus sign whenever two objects are not going in the same direction. If they are going in the opposite direction, we have to use the minus sign for one of their velocities when we are replacing the numbers in the equation. Now, if these two momentum are not in exactly perfectly opposite direction, then you cannot get the addition of, let's say, the momentum of helium, P. I should write P. So the momentum of helium nucleus, P of helium nucleus vector, plus momentum of asteroid nucleus, let's say asteroid nucleus, together their sum should be zero, which means their momentum should be logically in perfectly opposite direction. That let's try to understand this information. Let that sink in. That the moment of helium should be equals to minus the amount of astatine, which means magnitude wise they should be perfectly equal and they should be perfectly in opposite direction. That's the key idea. If the experiment shows us, as per the question says, that there was that these two particles did not eject in the exact same direction. So let's say helium is going this way, 204 is going that way. If that's the case, now these are two vector quantities. If you add these together, which are in opposite direction, you can never get perfectly zero. I mean, you cannot get two vector quantities which are not working in same direction, add one after another to get a zero resultant. If you want to get a zero resultant, there should be a third particle involved which should fill up that gap. Together, these three things, if they produce a closed polygon, which we call a closed polygon, in this case a closed triangle, then we can say that the combined resultant is zero. The total resultant is zero. That should give us a total sum of zero. So that's the key idea, because the two particles were observed to be going in not exactly in opposite direction. So there definitely should be some third particle involved, which direction was not in the alignment of any of these two, which direction was somewhere else in some other direction, so that the total momentum sum of all of these three arrows should ultimately give you zero. So key part you need to understand, this is going in one direction, this is not going in the same direction as this one. That's the key part information given to you. So there should be a third particle involved to compensate for the required momentum, so that the sum of all three of these momentums should ultimately add up to zero. The vector equation should be satisfied. Do I make sense in terms of the vector quantity thing? Did you understand
Yes,
what
sir.
happened? Did you understand what happened in the polygon rule over here? We discussed the
Sir,
polygon rule.
length গুলা কি same থাকবে নাকি
Not
different
necessarily.
হইতে পারে?
Length গুলো definitely same থাকবে না, সেম থাকতেও পারে, বাট থাকাটা বাধ্যতামূলক না। বাট দ্য কি পার্ট ইজ, সবগুলোকে আমরা যদি সিকোয়েন্সিয়াল অর্ডারে বসাই, উই শুড গেট এ ক্লোজ পলিগন। মানে হচ্ছে দুইটা ভেক্টরকে পাশাপাশি বসাইলাম, মনে করি দুটো ভেক্টর এরকম, থার্ড ভেক্টরটা হইতে হবে এরকম। সো অল অফ দেয়ার ডিরেকশন শুড বি ডিফারেন্ট। If two of them have different direction, the third one should also have a different direction. The third vector cannot be in the direction of any of these two, because that would also lead to a non-closed diagram. মনে করো এই থার্ড ভেক্টরটা, মানে this is the one of the very important part mentioned in the mark scheme, which you should also appreciate. We cannot have the momentum of the or the velocity of the third object aligned in any of this direction, because that would simply add up to one of these values. But ultimately you cannot get a closed triangle. To get a closed triangle with lines which are not in the same direction, the third line should be in an alignment that is not aligned with either of them. ঠিক না?
জি স্যার।
So that's the important bit. So if you have a look at the mark scheme, this is what they say. এটা ছিল কোশ্চেন নাম্বার কত জানো?
স্যার নাম্বার 10 স্যার।
10. Another particle or photon is emitted at an angle to the direction of alpha particle. So they have only mentioned an angle to the direction of alpha particle. If I was writing this, I would write that at an angle. I would have done so in this way. Another particle is emitted from the breakdown, which velocity is not in the direction of alpha particle or acetylene nucleus. I would mention both of them, that the velocity of the third particle is not aligned with either of them. That would basically score this whole mark as well, because they only mention that is produced at some angle with the alpha particle, but that would also make an angle with the Francium nucleus as well, not only with the alpha particle. If we have a look at the examiner's report, what they have to say for number D, very few candidates suggested that the simultaneous emission of another particle or a gamma ray photon. Instead, many suggestions were based either on the electrostatic repulsion between the acetylene nucleus and the alpha particle and the influence in some way or the Francium nucleus. So these are all wrong considerations, because the question specifically tells us that the Francium nucleus was initially stationary. So we cannot overdo that. Although they allowed 1 mark in the mark scheme of D, it says that allow 1 mark for Francium nucleus is not stationary. They allowed a mark for that, but I would not go for it. I would try to explain it in the logical way possible. These observations of that the momentum is not being conserved is actually the one of the main ways, or one of the primary ways, by which many new subatomic particles' existence was first denoted in the Large Hadron Collider. So whenever scientists are trying to find out the particle physics, whenever they are crushing high-speed hydrogen with high-speed hydrogen, or protons and protons are collided with huge force against each other, which were accelerated in some magnetic field earlier, and then they observe the lines at which different charged particles take, and they record them over a very high speed cameras, like super high speed cameras, which can operate at very high temperature as well. And from that point, they try to observe that how the visible particles are working. They, by looking at those particles, they sort of measure their momentums and everything. And if the sum of all the momentum is not zero, then they know that there must exist at least one more particle. There can be more than one particle as well. So now they know that they have to refine their research in the search of new particle which was produced in the breakdown of those hydrogen nuclei, which they couldn't observe for the limitation of their observation equipment. So they had to develop more precise equipment, or they had to take more frames per second compared to what they were doing. So we need to look for more particles. One of the key indication for that thing is that the calculated momentum of all the visible breakdown particles does not add up to zero. If that happens, then we can actually go for that calculation. It's a pretty interesting thing to work with particle physics. তারপর what can we go for afterwards?
Sir, 9:30 দিকে একটা ক্লাস আছে।
আচ্ছা, আমি 9:30 ছেড়ে দিও তোমাকে, don't worry. Tell me further problems. Anything else that couldn't make sense, we couldn't do? Question number 11 is actually a pretty interesting problem. You have to write a lot of equation over here and then simultaneously solve those equations. This question is essentially not difficult, but it can prove a bit challenging if you lack significant imagination.
Sir?
Yes.
Sir, question number 15.
Abdullah bolo.
স্যার এখানে এই যে 11 এ স্যার স্যার 11 এ B1 করতে গিয়ে স্যার এর ভ্যালু 9.81 ইউজ করতে বলছে, মাইনাস ইউজ করলে বলে রং ফিজিক্স। স্যার এটা বুঝি নাই, রং ফিজিক্স মানে কি?
দেখতেছি দাঁড়াও। A girl is running by a constant stream of meter per second at time t equals to 0. She passes a boy B. 11 এ
স্যার অন্য একটা স্যার, আই গেস স্যার এটা না
কোনটাতে? কোন
সেইটা না
কত নম্বরের মার্কস কিনা বলছে এটা?
স্যার আমি বাইর করে বলতেছি, তার আমি বাইর করে নিচ্ছি।
ঠিক আছে, দেখো, সমস্যা নো প্রবলেম। আচ্ছা, হাসান একটা কোন প্রবলেম বলছো? 15 বলছো?
স্যার, এই যে question number 15 স্যার।
Okay. Small stone horizontally with a speed of 4.0 meter per second falls to a vertical height of 1.96 meter before bouncing off a horizontal blade as illustrated in figure 3.1. Okay, boom and bang. Resistance is negligible for the ball as it hits the horizontal blade to the magnitude of the horizontal component of its velocity 4.0 meter per second. Show that the vertical component of the velocity is 6.2 meter per second. You just calculate it from the height. The component of the velocity and the both vectors configured the velocity of the ball as it is horizontal blade. So if this length given in your question is exactly 4 centimeter, well and good. If it's not, you extend it to become 4 centimeter. Then from the end point, you draw a 6.2 meter per second, 6.2 centimeter vertical arrow downwards. Complete this 2 by the triangle rule, you get the resultant. Velocity
number 25.
Extend করে নিন।
আচ্ছা, এটা এই given arrowটা যে exactly 4 centimeter দেওয়া থাকবে not necessary. তোমার ইনিশিয়াল ভেলোসিটি 4, সো এটা মেজার করে দেখো, যদি এক্স্যাক্টলি 4 সেমি থাকে well and good, you don't have to extend that. আর যদি 4 সেমি না থাকে
এক্স্যাক্টলি 4 সেন্টিমিটার না স্যার, 3 পয়েন্ট সামথিং, এটা এক্সটেন্ড করছি কেবল স্যার।
তাহলে ওটাকে 4 সেন্টিমিটার এক্সটেন্ড করে নিতে হবে, করে নিয়ে তারপর ওই লাইনটাকে তোমার মানে you can use this as a guide or as a given alignment that the examiners want you to draw with, but you shouldn't expect that the printed line is exactly to scale for your requirement. এরকম কোশ্চেন আরো আছে। আমরা যে প্রজেক্টাইলের শুরুতে এরকম একটা কোশ্চেন পাইছিলাম যে there was 2 arrows given, sorry প্রজেক্টাইল না, ইয়াতে measurement chapter শুরুতে the 40-degree angle was drawn with dotted lines, but they asked us to use our own scale to be drawn on that figure, remember?
Yes sir.
আচ্ছা, আব্দুল্লাহ কোনটা বলছো? নাম্বার 25 এর সমস্যা?
হ্যাঁ স্যার, নাম্বার 25
দেখতেছি, দাঁড়াও এক মিনিট। আচ্ছা, এইটা একটা খুব ভালো কোশ্চেন, বুঝার জিনিসপত্র আছে। 25 এর দাঁড়াও A ball is thrown vertically down towards the ground with initial velocity of 4.23 meters per second. The ball falls for a time of 1.51 seconds before hitting the ground. Rest is negligible, so that the downward velocity of the ball when it hits the ground is 90.0 meters per second. Okay. এখানে মার্ক স্কিমে ঝামেলা আছে। Let's have a look. মার্ক স্কিমে বলছে এটা allow to SF use of minus g maximum half, use of g 10, maximum 1 or 2, allow use of 9.8, allow 19 meters per second.
স্যার নাম পার্ট 2 টা দেখেন স্যার এই যে রং
square, use of minus g here, wrong phase is 0 out of 2. আচ্ছা বলতেছি এখানে কি হচ্ছে। I'll tell you what is happening. It's not essentially wrong if you consider all of your values properly. Let me tell you why that is. What you need to understand for this question, what they are saying, that the ball was thrown vertically downwards. A ball is thrown vertically down towards the ground with initial velocity of 4.23 meters per second, right? So considering vector sign, you should be what, positive or negative?
you should be negative sir.
Beautiful.
Downward.
If you understand that, then your math will definitely work out. So how we are going to write this equation? Let's say I'm going to write this equation as h equals to ut plus half at square. I'm going to write this exact expression. But whenever I'm replacing these numbers, I'm going to write these numbers in my own way. So I'm going to write minus 4.23 multiplied by 2 time 1.51 plus half into minus 9.81 into 1.51 whole square. This would give me a perfect answer. It's important that you do not mess up the sign of either of them. If you want to place the u as a positive number, you can choose to use the a as a positive number as well, because both of them are working in the same direction. In which case you are considering negative direction as the positive way. That is also okay. That's what the mark scheme tells you. But if you go for a conventional procedure, you have to perceive that the initial velocity should be also negative. Ultimately, my final answer is negative as well, because that's obvious, because the object is definitely falling down from its initial throwing point. So in terms of the vertical axis of displacement, it is going in the negative direction, which is perfectly all right. You just write the distance. You don't bother about the minus sign over here, because the question is asking you distance. Don't write the minus sign, not even within bracket. Just write the magnitude. What is important, that both of these numbers should be placed with the same sign in your equation. Writing minus g is not wrong. What the mark scheme should have told the students, or actually examiners make sense out of these statements anyway, so that's why they didn't go for that length, I believe. What they are trying to tell you is that the sign of u and a used in the equation should be same. Either both of them should be positive or both of them should be negative. That's what scores the full mark. Make sense?
Yes sir.
Beautiful. হ্যাঁ বলো।
তাহলে কি স্যার কোন স্কেলার কোয়ান্টিটি বের করার সময় আমরা সব ম্যাগনিটিউড কনসিডার করব সবকিছু?
Well, no. ভেক্টর কোয়ান্টিটি যদি ইকুয়েশনে যদি ভেক্টর সার্টেন কোয়ান্টিটি ভেক্টর হিসেবে দেওয়া থাকে, তোমাকে সেটা ভেক্টর কোয়ান্টিটি হিসেবে বাই করতে হবে। আলটিমেটলি তুমি তোমার মার্ক স্কিমে যদি সেই কোয়ান্টিটিটার স্কেলার ভ্যালু চায়, তখন তুমি আনসার লেখার সময় মাইনাসটা দিবা না। মানে হচ্ছে আমাকে ডিসটেন্স বের করতে বলছে, তার মানে এটা না যে আমি এখানকার সব ভেক্টর কোয়ান্টিটি গুলোকে স্কেলার ধরে ফেলবো। আমার ইকুয়েশনের ক্যালকুলেশন এটাকে ভেক্টর ধরে হিসাব করতে হবে, because that's how the equation was developed in the first place. But ultimately my answer should not bother with minus sign. I am asked to find out what is the magnitude of the displacement. That's the distance. That does not allow me to make all of these quantities into scalar. I think that answers your question.
Yes, which is
beautiful. Procedurally আমাদেরকে কারেক্ট ফরম্যাটে করতে হবে, ফাইনালি আনসার যেভাবে লিখতে বলে তার আনসার যেই ফরমেশনে চাই সেই ফরমেশন লিখতে হবে। ইউনিট দেখতে হবে যে ইউনিটে তারা সেন্টিমিটার লিখে দিছে নাকি কিলোমিটার লিখে দিছে নাকি মিটারেই চাইছে, কারণ ইয়াতে কিন্তু দেখবা হচ্ছে যে আমাদের ভ্যালুতে অনেক ডিফারেন্স আসে। কি বলে এই মার্ক স্কিমের আনসারে ইউনিট নিয়ে অনেক কাবজাব আছে, যে ইউনিট রিলেটেড কমপ্লিকেসি গুলো তোমাদের ও লেভেলসে ছিল না। ও লেভেলসে সবসময় মোরলেস কোশ্চেনে এসে ইউনিট দেওয়া থাকতো, তোমাদের জাস্ট ক্যালকুলেশন করতে পারলে হতো। এখন ইন ইওর এস লেভেল অল দ্য ওয়ে আপ টু লিডিং টু A2, what you'll see that in most cases the given information are not in SI unit. They have given all the lengths in millimeters or centimeters or something other than that. The masses are given in grams and the temperatures are given in degrees Celsius, whereas for the equation you are requiring them in Kelvin. So in many cases, or I'd say in most of the cases, the available numerical information would require some sort of conversion for their unit. So you should be careful for that. আচ্ছা আমি এই কোশ্চেনটা একটু আলাপ করি উই অ্যাকচুয়ালি 9:30 বাজে তাই না আচ্ছা we can call it a day for today
Yes.
we'll pick up more problems from this worksheet in our next class তোমরা এই ওয়ার্কশিটটা করো এই ওয়ার্কশিটটা মোটামুটি ডিসকাশন করা শেষ হলে আমি তোমাদের প্রথম দুই চ্যাপ্টারের ক্লাস টেস্টের পেপার পিক আপ করার জন্য একটা ডেট দিব বা একটা 2-3 দিন টাইম দিব তোমরা এর মধ্যে কোচিং থেকে এনে পেপার পরীক্ষা দিবা অলওয়েজ মক যে সিস্টেম হয়েছিল সেই সিস্টেমে পরীক্ষা দিতে হবে ক্লোজ এনভেলপের ভিতরে কোশ্চেন থাকবে তোমরা প্যানেলের সলিউশনে পরীক্ষা দিবা তারপর হচ্ছে সেগুলো আগে যেভাবে করছিল ওইরকম অথবা গুগল ক্লাসরুমে তোমরা পেপার সাবমিট করার প্রসিডিউরটা নিয়ে আমি কাজ করতেছি যাতে করে আগের থেকে জিনিসটা আর একটু স্মুথ হয় আর একটু অর্গানাইজড হয় যাতে করে আমাদের ঝামেলা কম হয় সো লুকিং ফরওয়ার্ড টু দ্যাট আর হচ্ছে জালাল আমাকে কালকে 9টার সময় ফোন দিবা মেসেঞ্জারে
বাই স্যার
আব্দুল্লাহ বিন জালাল
Bye, sir.
আসসালামু আলাইকুম
Assalamualaikum.